Good morning, everyone. Am I audible?
Yes, sir.
Screen is visible?
Yes, sir.
Okay. Okay, once again, very good morning to everyone. In the last week, we were discussing about how to design the horizontal curve with respect to the various element. Especially, we have seen the super elevations, how the 4 steps is following, and the different way we are designing the super elevations to negotiate the centrifugal force. Followed by the second component is nothing but the widening of the pavement, particularly when it is coming to the hilly stations, how the extra widening we are providing in the horizontal curve with respect to the mechanical as well as the psychological behavior of the driver with respect to the two components we design the extra widening of the pavement. The last component of the horizontal alignment is nothing but the transition curve. So what is transition curve? Basically, the first class of the horizontal curve or the second unit, I have shown that the horizontal curve, it is a circular curve which we are providing to change your directions from the one direction to the another direction. So we cannot provide the 90-degree, the vehicle will feel the comfort and the turning issues when you are providing this kind of the rigid turning. So that is the reasons we are providing the circular curve from the straight path. Then again it is connecting to the straight path. So the straight path to the circular curve, suddenly we cannot connect it because there is a lot of issues might be happening like the jerk or the discomfort or the other issues probably it would have happened on the field. To avoid those kind of the issues from the straight path where you are coming, the connection between the curve and the straight path in the middle we are providing the transition curve. It might be starting from the infinity and it is reaching with respect to the radius of the circular curve. So this is the angle it is happening for the reverse directions also. So that is the reasons the transitions curve is, it is a kind of a transit only, one stage to another stage you are transferring. So instead of the sudden changing, we are providing the gradual changes to achieve that radius what we have provided. So that is the way we have explained. It is a non-circular curve which we are introducing between the straight and circular curve. Okay, so which is varying from the infinity to the desired radius what we want to provide. That gradual incremental we are providing, which ultimately giving the gradual introductions of the centrifugal force. So that is explained as an or the defined as the term of the transition curve. The next, what is the objective? Yes, the previous slide itself I told that there is a chance of jerk on the vehicle due to the sudden turning. Also, the driver might not be feeling comfortable with respect to the steering type because the steering is varies with respect to the vehicle to vehicle. So to avoid so those kind of the issues, the main objective is to providing the transition curve between the tangent point and the beginning of the circular curve. So it is enable the driver turn the steering gradually for his own comfort and the safety. So that will be the second objective. Third will be the to provide a gradual introductions of the super elevations, because in the turning we were providing the super elevations, right, with respect to the outer edge and the inner edge. So this is what we have studied in the last week classes. So the gradual introductions of the super elevations we have to provide. Then they provide the gradual introductions of the extra widening, so wherever it is required. Finally, for the aesthetics appearance also, we are providing this transition curve with respect to the proper side distance. So this is an objective of why we are providing the transition curve between the straight and the circular curve. And when it is coming to the type, it has a three types: spiral type, cubic, parabola, and lemniscate. So this is the three types we have with respect to the type of the transition curve. But Indian Road Congress IRC recommend the spiral as the best transition curve for providing on the field, because it is fulfill the requirement of the perfect transition curve, which means that it is rate of change of centrifugal is gradually it is happening, so the accelerations are consistent, so that is the reasons we are providing. Also, I mentioned that from the straight to the circular curve, it might be starting with the infinity and ending with the radius. So this kind of that gradual changes are happening with respect to the spiral type. So that is the reasons the IRC's recommended spiral is an ideal type for the designing the transition curve. So this is just an overview of the transition curve, why we want to provide, what is the specific objective, and what are the different types are there to achieve on the field. So we have the different kind of that design steps. So directly we will discuss what is that equations. Probably with respect to the problem, you might be getting the clarity. So there is a three cases are there. One is rate of change of centrifugal acceleration. So how the centrifugal acceleration C is changing. So according to that, what type of or what is the length of the transition curve we need to provide it. Second will be the super elevations, how the rate of introductions of super elevations we are providing. So according to that, the length of the transition curve is changing. The third case will be IRC standard equations. So that is we are estimating with respect to the directly in these three cases, which one will be coming as a maximum length, so that we are providing as a final length of the transition curve. So the first case is rate of change of centrifugal acceleration. The length is nothing but 0.0215 v cube divided by CR. So here the C is nothing but how the rate of change of accelerations are there with respect to the centrifugal behavior. So that C is estimated 80 divided by 75 plus V. So here the V is defined with respect to the kilometer per hour. So in your equations, if it is there, you change that one and then you can try to apply in this particular equation. So this is the first case, rate of change of centrifugal accelerations. The second, the way how we are introducing the super elevation, there's a two type of the way we can introduce. If the pavement is rotated with respect to the center line of the road, then with respect to the inner edge. So with respect to the center line, En divided by 2, and with respect to the inner line, it is E into N. Okay, so this E is nothing but we have a seen E into B. E is the super elevations, B is nothing but the total width including the extra widening. So that is the reasons the equation is slightly modified. E into N W plus W into E. This is the total width divided by 2. Getting my point? So instead of the capital E, we are substituting E into W plus E. So this is nothing but the total width, capital B. This might be the 7 meter for the two lane. So this might be extra widening, you might be estimated 0.5 meter. So the overall value is 7.5 meter. So that is the way we have modified the equations. So this N is nothing but basically the introductions of rate of super elevations is defined with respect to 1 in N. So that means 1 in 100, 1 in 150. So this is the way we are explaining. So this is nothing but the representations of the value of N. So 150 or the 100 will be the N we need to substitute in that particular equations. Else, if it is not given directly or the percentage or something might be given, the last class I have shown how to convert 1 in N or 1 in X. So that way you have to change your equations, change your value, then you can identify what will be the n value. In case if you want to make it as a trick in that particular equation, so that might be one of the simple indirect component which need to be estimated using the simple mathematic logic. So this is with respect to the rate of introductions of super elevation. Then the final will be the IRC recommendations. It has two empirical formula. One is with respect to the plane and rolling terrain, 2.7 into V square divided by R. Second will be the mountain and the steep terrain, V square divided by R. So this is the length of the transitions curve. So three cases are there. In this three cases, which will be the highest value? So that will be the final length of the transitions curve. So hope you might be getting the three cases. Probably I will explain with respect to the one or two examples. Then you will be getting the more clarity. Then finally we want to shift the transitions curve. So the shifting of the transitions curves are happening S is equal to L square divided by 24 into R. In case if specifically if they are asking this shifting of the transitions curve in that problem, you try to identify it. Else you just stop what will be the overall length of the transitions curve. So this is with respect to the detail about the identifications and understandings of the length of the transitions curve. Let me show one example. So in the first problem, so they have a given, they were asking calculate the length of the transitions curve and shift using the following data. Okay, they were asking the LS and the S value with respect to the given data. What is the data they have a given? What are the data they have a given? One is the design speed as a 65 kilometer per hour, the radius of the curve 220 meter, allowable rate of super elevations 1 in n, 1 in 150 they have a given. Then they given the guidelines, the pavement rotated about the center line of the pavement. The center line they have a given. One is the outer edge, the second will be the center line. There are two probability. In that probability, it is rotated with respect to the center line. So according to that, you have to choose the what we can say equations. Then the pavement width including the extra widening is 7.5 meter. So let me write what are the data they have a given. V is given as a 65, radius of the curve R is given as a 220 meter, allowable rate of super elevation 1 in n is equal to 1 in 150. So the n value is nothing but 150. Extra widening they have a given W plus WE is equal to 7.5 meter. So this is the details they have a given. Let us estimate the value with respect to the three cases. The case 1. Case 1, what it is happening, the length of the transitions curve, we are estimating with respect to the allowable rate of centrifugal accelerations. So that means the equations LS is equal to 0.0215 V cube divided by C into R. But I have told that the C is nothing but the allowable rate of centrifugal accelerations. It is given as in different equations 80 divided by 75 plus V. And V is nothing but the speed. It is given in the problem 75 plus 65. So when you are applying, you will getting the value of the C 80 divided by 75 plus 65. So overall it is 0.57. The unit for the accelerations is nothing but meter per second cube. So this is the value you are going to substitute in the given equations. 0.0215. V is nothing but 65. 65 cube divided by the C is estimated as 0.57. Radius is given in the problem as 220 meter. So when you are substituting all the value, you will be getting the length of the transitions curve with respect to the allowable rate of centrifugal accelerations when you are allowing the value of C as 0.57 meter per second cube. So the value is 0.0215 65 cube divided by 0.57 into 220. So I'm getting the value of 47.085. So I'm just to make it as 47.1 meter. So this is a case 1 with respect to allowable rate of centrifugal accelerations where you need to estimate the value of the C. Then when you're applying in the equations of length of the transitions curve, you will be getting the value of 47.1 meter. Then the case 2 is nothing but with respect to the introductions of rate of super elevation. So how we are introducing the allowable rate of super elevations introductions. So the equations, what we have seen in the sense, there is two equations are there. One is with respect to the center line and another is with respect to the outer edge. So here they have given the clearly the equations or the super elevations is introducing with respect to the center line. So the equation is nothing but LS is equal to En divided by 2. So this is the equation. So E is equal to, we know that E into B, right? So E into N divided by 2 into W plus WE. So this is an equations. We know the N value. We know the value of W plus WE, but we don't know the value of E. E is nothing but super elevation. So we need to estimate the super elevations which we already seen in the previous classes. So the super elevations equations, we know that E is equal to first step V squared divided by 225 into R. So I think I already circulated the material. In case if you go through the material, probably it will be easy for you. But anyway, it is okay. I'm just explaining again how to estimate. So V is nothing but 65 square divided by 225 into R. So E value what we are getting. So this is by considering the 75% of the centrifugal actions. So initially we are using this equation 65 square divided by 225 into R value is nothing but 220. So I'm getting the value of 0.085. Okay, but this value is the greater than the allowable value of 0.07. So the second step, what we are doing in the sense, we are assuming the E value as 0.07. So when you are allowing the maximum allowable super elevations, you need to recalculate the value of coefficients of frictions, right? The lateral coefficients of friction. So the step 3, what we are doing, E plus F is equal to V square divided by 127 into R. So F is equal to 65 square divided by 127 into 220 minus 0.07. So F is equal to 65 square divided by 127 into 220 minus 0.07, and I am getting the value of 0.0812. So I am making 0.081, which is less than 0.15. So this is an allowable coefficients of lateral frictions, and the estimated F value is less than that maximum allowable. So we can conclude our second step itself. The coefficients of friction is nullifying when you are assuming the maximum value of E as an 0.07. So this is another track how lengthy it is going for the estimations. So once you estimated the value of small e, you can substitute all the value here. So E is nothing but 0.07, N is nothing but 150 divided by 2. W plus W is nothing but the total roadway width. So including the extra widening. In case the extra widening is not given, the WE you have to estimate exclusively. So which we have seen in the last class, mechanical as well as the psychological. According to that, the two components when we are adding, so you might be knowing what will be the extra widening width. So that will be added with the number of the lane what it has been given. 2 lane means 7 meter. So after the estimations only, overall the problem it is given 7.5 meter. So when you are applying the 7.5 meter, you come to know what will be the length of the transitions curve when it is considering the allowable rate of introductions of the super elevations, which is nothing but capital E. So substitute the value 0.07 into 150 into 7.5 divided by 2. I'm getting the value of 39.375. So I'm assuming 39.4 meter. So this is with respect to the case 2. Okay, case 2 with respect to the super elevations, how the length of the transition curve is provided. Then the case 3 is nothing but the IRC recommendation. The case 3 is nothing but the IRC recommendations. So I think the problem is not given any detail with respect to the terrain type. So we assume it is in a plain terrain and we can use that IRC equations. LS is equal to 2.7 into V squared divided by R. So 2.7 into 65 square divided by 220. So the LS value what we are getting as per the IRC 2.7 into 65 square divided by 220 and getting the value of 51.8522. So I'm approximately fixing 51.9 meter. So this is with respect to the IRC. So now the length of the transition curve is the maximum value what we are getting when we are comparing the case 1 with respect to the centrifugal acceleration, case 2 the super elevations, and the case 3 is nothing but IRC empirical equations. So out of these three, the empirical equations 1.9 is the maximum one. So the length of the transition curve is finalized as an 51.9 meter. So this is the way we have to estimate the length of the transitions curve. In continuations of that, the shifting, how it is happening, that they were asking. So the shifting, that means the incremental, how it is happening, what is the interval, so that we need to estimate. So the shift, how the gradual incremental is happening, right, infinity to achieving the radius, how it is happening. So that equation is LS equal to LS square divided by 24 into R. LS square is nothing but 51.9 maximum what we are getting from the previous calculation. 24 into R is nothing but 220. So when you are substituting all the value, so you will be getting the value of shift 51.9 square divided by 24 into 220. So I'm getting the 0.51. So 0.51 meter is the final value. So this is in a one complete problem, how the estimations are happening. It is a simple cases, 3 cases are there. Most of the data they might be given. If not given, you assume with respect to the IRC standard, and some component might not be given directly in the problem, like the super elevations and the extra widening. So that value you need to be estimate by using the previous calculations, like the 4-step super elevations calculations, then the extra widening equations with respect to the mechanical and the psychological behavior. So this is an equations, and moreover for the case 2, super elevations with respect to the center line or the outer edge. So two different formula is there. If the center line, En divided by 2. If it is the outer edge, only En. So the calculations need to be calculated accordingly. And case 3, whether it is the plain or the rolling terrain or the mountain or the steep terrain. So according to that, the equations is changing, that you have to adopt it. So this is some modifications or the slight tricky they might be given in the equations. So in case if it is given the meter per second, that value you convert to the kilometer per hour, the design speed, and the remaining all the equations you just to follow the same as it is what in the shown in the particular problem solutions. Okay, so this is with respect to the first problem, what the data has been given. The same problem, the second one, a national highway passing through the rolling terrain in a heavy rainfall area has a horizontal curve of radius 500 meter. So the radius is given. Design the length of transitions curve using the following data, which means that the design speed of the vehicle is given as an 80 km per hour. So V is given 80 km per hour. Allowable rate of super elevations 1 in 150. The capital N is given. In case student in the problem, if they given only this much, a national highway passing through the rolling terrain. So they given the national highway with the radius of the 500. So typically we used to assume the speed of the vehicle is 80 meter. Allowable rate of super elevation is 1 in 150 as per the IRC standard. So this is the assumptions you have to make it. Then the width is excluding the extra widening. That means W plus WE, they given W as an 7 meter. WE is not given. So the WE you have to estimate. WE is equal to mechanical widening plus psychological widening. So we have the equation. So according to that, you have to estimate it. For calculating the extra widening, we have the equations. Okay, the n will be the number of the lane. So the 2 we have to assume it, because it is a 7 meter. No need to assume, it is a 7 meter it is given. So automatically it is coming as a 2-lane road. The radius is given. The length between the wheel faces 6 meter. Previously I have told we have to assume it. Then radius and the speed is given. So according to that you have to estimate it. At the same time, super elevation is required, which is not given in the problem. So you have to estimate using your typical equation V squared divided by 225 into R. Then the second step, you have to check it with respect to the 0.07. If it is exceeding, fix this value, then go for the next step, lateral coefficients of the frictions. Then you have to finalize it. So this is the way the data has to be identified and estimated. Then the 3 cases are there. The case 1 is nothing but the allowable rate of introductions of centrifugal for C. So according to that you have to estimate. Case 2, super elevations introductions. Once you estimated the E value, then at the same problem we need the extra widening, because equation super elevation is also there. E into what we can say, E into that equation is nothing but B. Yes, E into W plus WE, which is nothing but B. Okay, in this B, W is given the 7 meter and the WE you have to estimate it. Then you can apply in that particular equations. EV divided by 2, or in this case divided by 2 it won't come, because it is with respect to the inner edge rotations instead of the center line. Then finally the length of the transitions curve as per the IRC standard, they have given us a rolling terrain. So it is coming under the first category. So according to that, the equations might be chosen with respect to the speed of the vehicle and the radius of the horizontal curve. So since it is the same kind of the problem, I'm not solving. So you just take it as an assignment or the homework. So I will create the model. So not only in this particular problem, according previously whatever we have covered, and one more chapter is that vertical alignment. So altogether, I might be circulating few problems with respect to the very short deadline. So based on your submissions as well as the way how you solve, so according to that, it can be evaluated for the 10 marks. So this is with respect to the transitions curve. Any doubt from the transitions curve, student? Any doubt? So currently we are here. Highway geometric design is your second unit. So the final component is nothing but the design of vertical alignment. So where we are going to study about the different gradients and different kind of that estimations are there. It might be the valley curve or the summit curve. That means which is nothing but the upward and the downward. So probably I will very quickly within 2-3 minutes I will give the quick introductions about the vertical alignment and the detailed design and the estimations we can see in the tomorrow class. So it is very simple and everybody well known. The horizontal alignment is changing the directions from the one direction to the another direction. But the vertical alignment is nothing but the gradual upward as well as the downward things are happening. So that means the changes are happening with respect to the elevations, the given profile. Okay, so that is what we have explained. The vertical alignment is nothing but the elevations or the given profile of the center line of the road. So that is the things we are considering as a vertical alignment. Basically it is influencing with respect to the speed of the vehicle and what will be the accelerations, and definitely the main important parameter is side distance, because the downward direction is there, suddenly the upward when we are going, so the side visibility is definitely it is affecting. Also the upgrade downgrade and when it is going, the comfort of the driver is definitely it is influencing. So where it is coming to the horizontal curve and all, how the centrifugal force is playing the major role. So likewise when it is coming to the downward and the upward elevations and all, the comfort level of the driver is ultimately affecting. So this is just an view of the vertical alignment where the gradient, summit and the valley curve types are playing the major role. So the gradient is nothing but how much percentage the changes are happening. Okay, suddenly we are not falling, right? The gradual increase incremental are happening. It is the gradual increment and the downward also it is happening. So the gradient is defining with respect to the rate of rise, okay, rising, the rate of fall, okay, with respect to the length of the road with respect to the horizontal, how the changes or the rate we are providing. The simple understanding 1 in x. So 1 unit vertically if we are increasing, how the incremental or the decrease we need to provide with respect to the horizontal unit. So that is we are defining with respect to the terms of the gradient. It might be explained 1 in x or it might be explained in the percentage. N in 100 percentage we might be explained. So this is a two way we are providing, and there is a two type of the gradients are there. One is a summit curve. So upward it is coming and it is going downward. The valley curve is, it is going the downward and it is going for the upward. So concave and convex type only. So it is explaining with respect to the positive as well as the negative. So when the positives are happening, this is the incremental. So n percentage or plus 1 in x. So this is an ascending increasing. When it is coming to the minus n, it is the descending, it is a decreasing, minus 1 in x. So this is a two way we can represent the gradient, positive n and the negative n. That means the plus 1 in x minus 1 in x. So it has a two type, increasing and the decreasing. It is a summit curve. Decreasing and increasing, it is a valley curve, which we used to refer as a concave and convex type. So this is with respect to the gradient, how we can understand it. But when it is coming to the IRC, it has a four typical gradient. One is the ruling gradient, second will be the limiting gradient, exceptional gradient, minimum gradient. So the ruling gradient is nothing but the maximum gradient the designer planning to achieve on the vertical given profile on the field. So what is the maximum gradient we are providing with respect to the designer attempt on the vertical profile? So that is ultimately depending upon the what type of the terrain, what is the length of the grade, and what will be the speed of the vehicle, pulling power, presence of the horizontal curve, and the mixed traffic conditions. So this is the ruling gradient, or we can say the design gradient, or we can define as a maximum gradient also. So the different three terms we can define this particular maximum gradient, what the designer attempt to achieve on the field of the vertical profile what it is given. The second will be the limiting gradient. Sometimes some locations we cannot provide the ruling gradient steeper than the ruling gradient where we are trying to provide. So that is considering as a limiting gradient. One, the example is the hilly road where we are providing and when we are trying to adopt the limiting gradient. It is ultimately depending upon the topography and the cost of the constructions of that particular road. So this is steeper than the ruling gradient, limiting gradient. Third will be the exceptional gradient, which is more steeper than the limiting gradient what we are providing. Some unavoidable situations is there where we might be providing. So it is with respect to the field issues, not with respect to the designs oriented. So the with respect to the field conditions, same the topography and the cost and what are the environmental and the other constraints are there. So according to that, the exceptional gradient we are providing. Probably it is considering for the short distance only, the stretches which might be less than 100 meter. So this is the exceptional gradient which is steeper than the limiting gradient where unavoidable situations are there where we need to provide it. Then the critical length of the grade, so where the maximum length of the ascending gradients which we need to be considered with respect to the loaded truck. So the loaded truck speed is considered. That means if it is traveling in the 40 km, it should not reduce the speed while passing that particular ascending gradient. So according to that considerations, what kind of the grade we are providing, so that is considered as a maximum length. Okay, sorry, that is considered the critical length of the grade. So the provided the maximum length of the ascending grade by considering the loaded truck, the truck should be operate without reducing the speed. So that is termed as the critical length of the grade. So basically, which we used to assume as a speed as a 25 kilometer per hour. According to that, the critical length of the grade is estimated. Finally, it ultimately depends on the size of the vehicle, power of the vehicle, load, how much it is carrying, and the initial speed. So this is the things, and the final one is the minimum gradient. So wherever it is not required, we cannot stop without the gradient, right? At least for the draining the rainfall or avoid the water lock, we have to provide some minimum gradient, right? So that is considering as a minimum gradient where the things are not required, but still we need to provide by considering the rainfall drainage situations. So it might be sufficient when we are providing 1 in 500 for the concrete and 1 in 200 for the soil drains. So according to the drain type we were providing. So this is the four major terms with respect to the gradient. It might be look simple, but it might be keeping in the mind and understanding it make us some difficulties. Few of the gate exams I have seen the they given the definitions and they were asking this is the what type of the gradient, and sometimes they were asking with respect to the rank with respect to the steeper, so which one will be the higher or the lower. So like that they were asking for the four type of the gradient. First will be the exceptional, first one will be the previous slide what we exceptional, then the limiting will be there, then the maximum will be there, or the first one what we have seen, then the final one will minimum will be there. So according to that the ratings are happening. So that is the one way how they can ask this typical questions. Or the second will be as per the IRC we have the standard ruling limiting and exceptional gradient for the different kind of the terrain type. So 3.35% is 6.7%. So this ranges also expected in the your competitive exam. So for the mountain terrain, what will be the limiting gradient? 6%. So the percentage they given us on a four options, we have to choose it. So this kind of the things also we can expect for your competitive exam. So keep this table in your mind. So the value of gradient as per the IRC standard. So here I'm just concluding the today's sessions. So today we have seen the two major component. One is the transitions curve. So with respect to the typical three cases, how we are providing the length of the transitions curve from the straight to the central curve, which is changing from the infinity to the radius of the curve. In these three cases, one is with respect to the rate of allowable rate of centrifugal accelerations, and we have the equations based on the C value. Then the second will be the allowable rate of super elevations E value. Okay, so then the third will be the estimations with respect to the IRC empirical equations. So if the questions might be expected, but it is a simple and straightforward, but only it takes the lengthy procedure. They won't give the extra widening, they won't give the super elevations. In that particular point of time, you have to estimate super elevations as well as the extra widening, then you have to apply on the equations. Finally, for the three cases, which will be the maximum one, so that can be finalized as a length of the transitions curve. Sometimes the problem shift they are asking, based on the maximum value, speed and the radius, you have to estimate what is the shift value. So this is the things we have covered, and the final components we have ended. So that is nothing but the vertical alignment, the basics of the vertical alignment and the grade. We try to understand it. Under the grade, the gradient, four different type of the gradients are there with respect to the maximums, limiting, exceptionals and the minimum gradient. Other than that, with respect to the loaded truck, how the critical length of the grade can be estimated by assuming the 25 km per hour. So this is the components we have covered in the today class. The final component is nothing but the summit and the valley curve. So that means the upward and the downward. That means up and down, then the down and up. Okay, so the changes is how it is given. So the length can be estimated with respect to the different equations. So with that equations and the simple two or three problems, we try to understand that particular term, and we will conclude our second unit by the tomorrow class. So this is the overview about the today lecture and what we are going to cover in the tomorrow class. Any doubt from the student side? Okay, if there is no doubt, I will end.